Hi, I'm Clive. This is an introduction to the Proof app, how to navigate it, and what content it covers. It's about the UK A-level standard. You navigate to the app from the standard URL. The URL is also given below. To get to the Proof menu, go to the app main menu and then select Pure. From this sub-menu, find the button for Proof, press that, and it will take you to the Proof app. Or go to the topic maps and start at statements. Then you can go to the home page of Proof by just clicking on start this topic. In both cases it will take you to this page. One of the most fundamental ideas in a proof is the idea of a statement. And a statement is a collection of words that is either true or false. And proofs are about starting with true or false statements and trying to deduce usually something that's true. Now there are some preliminary ideas in proof, such as what are the items that we're dealing with? What are the most basic atoms that we're dealing with? And I've got the analogy of building a house from bricks and wood and screws and nails. And we don't question those, we just use them. And it's the same in a proof. We have to decide what are the most elementary building blocks that we're going to use to build our proofs from. There are two other things. How do we combine those atoms together? For example, nails and hammers and wood and screwdrivers and drills in order to build a house or any other building. So we need some rules on how to put our atoms together. In addition, for mathematical proof, we have other rules, which are the rules of logic. How do we know that we can get from one step in the proof to the next? Ultimately, we have to know what those basic items are and not question them. Now in proofs, we're normally dealing with the properties of number systems. And the most basic properties of those number systems are given here. We're normally introduced to those and we don't question them, we just take them for granted. But I think it helps if we make ourselves aware of those very basic properties of numbers that we don't question and we can use in proof as always true. When we're considering a proof, we have to be clear, what is the proof about? Is it a proof about integers, or is it a proof about real numbers, or is it a proof about matrices, or is it a proof about vectors? And why that's important is it tells us which of the properties and rules that we can use in this particular proof and which ones we can't. Then the rest of the app goes into how do we interpret the statement or claim or proposition that we're given so that we know how to tackle it, what we're assuming is true and what we're trying to prove. And here are a list of statements that are converted into if-then form, which is usually a simpler way, a clearer way to start your proof. Then the rest of the app is divided into proofs about particular number systems, such as proofs about integers. And proofs by cases is a very useful technique to use within number theory or proofs about integers. There's a section on real number proofs, and again splitting the situation into cases, but here we are splitting normally the real numbers into negative, positive and 0 as a starting point. There's a section on counterexamples and why that's important in showing that a particular claim or proposition is actually false. There's a section on geometric proofs, some very basic Euclidean properties, but shown in the form of other proofs so we can see how you tackle a proof for other subject areas. Then the final topic I've got currently is proof by contradiction, which is a very powerful proof technique used when other proof techniques can't tackle the particular problem. And there's a very systematic and structured way to tackle proof by contradiction that hopefully I make clear here. As I come across other examples, I'll add them to this particular app. Also at the end is a link to useful resources, both books and online materials that you can use to extend your understanding and skill in writing proofs, using my app as an introduction to this particular topic. Hopefully you find this useful, and I hope you start to enjoy writing mathematical proofs. Goodbye.